Let's go ahead and see how we can compute this ANOVA test using Statcrunch. So this question says, the accompanying table gives amounts of arsenic in samples of brown rice from 3 different states. The amounts are in micrograms of arsenic, and all samples have the same serving size. The data are from the Food and Drug Administration. Use a 0.05 significance level to test the claim that all 3 samples are from populations with the same mean. Do the amounts of arsenic appear to be different in different states? Given that the amounts of arsenic in the samples from Texas have the highest mean, can we conclude that brown rice from Texas poses the greatest health problem? So for an ANOVA test where we're testing to see if the means from 3 or more groups are the same or if one of them is different, this should always be what we select for our H0 and H1. H0 always says that the means from all the different groups are the same, and H1 says at least one of them is different. It doesn't mean that all of them have to be different from one another, but at least one of them is not the same as the others. So again, remember, the null hypothesis says that all the means are the same, and the alternative hypothesis says that all the means, or excuse me, at least one of the means is different from the others. And in this case, the claim said, we said test the claim that the 3 samples are from populations with the same mean. So in this case, the null hypothesis is the one that says all the means are the same, so that is the claim in this particular problem. So now we need the test statistic. To find the test statistic, we're going to use Statcrunch. We're going to go up here to the little blue icon that has the data. And to open in Statcrunch, we're going to click the little blue box in the top corner and select Open in Statcrunch. So a common problem that occurs in Statcrunch sometimes is exactly what we see here, which is that the labels for the 3 different states in this case, or whatever the labels are for the columns you're in, actually got printed in the first row, but that should be data in the first row. The names should actually go up here in this gray section for the titles. So you're going to need to just adjust that really quick so you don't get errors in your output. So I'm just going to come up here to the gray bar at the top for the titles and just type in, we'll just abbreviate for simplicity, Arkansas, California, and Texas. And then this first row, let's just delete it. So I'm going to click on it, right click, and choose delete row. So now this looks better. This is what I want, where the titles of what the 3 columns are representing are up here in the title section, and then the white section that has the grid only contains the actual data. So that looks good now. Now that we have that, to run an ANOVA test, we're going to go to the Stat key, choose ANOVA, and one way, because we're doing a one-way ANOVA test. For the columns, we're going to select all the columns here by just clicking on one, holding the Shift key down, and then clicking on the last one. That will highlight all 3. Or you can click the first one, hold the Control key down, and then click the other ones one at a time, either way. And that's all we need to change here. So we're going to come down and click Compute. And now we have everything we need. So the test statistic is right here, the F-stat, that's the test statistic. And then the p-value we can see is right here. So right now we were looking at the test statistic, so I'm going to go ahead and copy that. And we're going to go back over to our problem, paste in the test statistic right here. Now we wanted to round to 2 decimal places, so I'm going to go back. Oops. So we now have 0.0196. So the 01 is the decimal place I want to round to. I look 1 digit after the 1 and I see a 9, which means I'm going to round that 1 up to a 2. And that's it. Now we need the p-value. Again, that was provided here. So the p-value says that, it didn't give us an exact value, but it tells us the p-value is less than 0.0001. And that's enough information because here we were asked to round to 3 decimal places. So we can just put in 0.0000, and that's enough accuracy. So now let's think about what happened. We got a p-value here that was very, very small. For sure, it was less than the significance level that we had in the problems in the hypothesis test to begin with. So again, when the p-value is less than the significance level, our conclusion is to reject the null hypothesis. So here, the null hypothesis said that all the means were equal, and we remember from earlier that that was the claim. So we are going to reject the null hypothesis, which means we did reject the claim. So let's see how this is worded. So we need to say there is or is not sufficient evidence at the 0.05 significance level to warrant rejection of the claim. So again, we said we are going to reject the claim. So there is sufficient evidence to warrant rejection of the claim that all three states have. And remember, the claim said that all the means were equal. So we would say the same mean arsenic content in the brown. Finally, I'll let you pause the video here to just go ahead and read all three of these. But this is asking, given the amounts of arsenic in the samples from Texas, or that the samples from Texas have the highest mean, can we conclude that brown rice from Texas poses the greatest health problem? So the answer, put simply, is no. All we can conclude is what we saw in the alternative hypothesis here. So we claimed that all the means were equal, and we rejected that claim. So all we can say is that we don't think that all the means are equal to each other. We can't go a step further from that, and unless we do extra work that says specifically that one state is higher or one state is less healthy or anything else. So we would say here, let's see, here we go. The results from ANOVA do not allow us to conclude that any one specific population mean is different from the others, so we cannot conclude that brown rice from Texas poses the greatest health problem.